Hello to everyone. Now we discuss the topic is differential phase shift keying. Next slide. Now we see the agenda. First one is the introduction to Dpsk, and then why we use Dpsk and how Dpsk works, and then transmission and receiver block diagram and comparison of Dpsk with other modulation and advantage of Dpsk and disadvantage of Dpsk, and then application and future trends, and then conclusion. Introduction to Dpsk is a differential phase shifting is a type of digital modulation. It transmits the data by encoding the phase difference between consecutive symbols, and then Psk is a phase shift keying. The Dpsk does not require the receiver to know the observed phase of carrier signal. The information carried, the carrier signal is changed the phase between one symbol the next symbols, and then Dpsk is maintain the coherence phase reference is difficult, is commonly used for fiber optics and in satellite communication. The next slide. This is the diagram of Dpsk. So Bpsk input is the receiver input, and the delay of one data bit is the delay bit, and then it is the compare between previous and then current signal, and then there is a multiplexer, so multiple between current and previous signal phase shift keying, and the integrated over one data bit means it is reduce the noise, and then here is multiplexer output give that here, and then the demodulator output printed zeros and ones in the next slide. Why we use Dpsk? Dpsk difference phase shift keying. It is to transmit the data in smooth way. The Dpsk is simplified. It's removing the need of absolute phase reference. It's highly restrict the phase noise. It's often we use a frequency times frequency is travel in unnecessary noise. Dpsk is reduce that noise. It's commonly we use the real world communication channels, and then the Dpsk ideal systems maintain the synchronization is difficult and expensive, and then compared to conventional Psk is hardware is complexity is reduced, and then it provides the good trade-off between communication reliability. Next slide. This is a diagram of Dpsk. The Dpsk is a technique of Bpsk. There is no reference phase signal. The transmitter signal itself can be used as the reference signal. Now we see the diagram. The signal data input is the receiver of input, and then external we are no. The external the data of input is the same, means the input is 1. The data of input is different, means the output is 0. The 1 bit delay means thus compared the current data and then previous data is compared here for 1 bit delay, and then balance modulator means carry the signal, and then Bpsk means the output of zeros and ones. That is next slide. Transmission and receiver block diagrams. The Dpsk transmitter consists of data input. The phase modulators transmission the channels. The differential encode compares the current input and then previous of output and the compare the phase changes. And then the Dpsk receive the delay elements and the phase comparator and the decision circuit and the data output. That's all. The next one, the delay elements hold the previous comparison and the current one. The next one, the phase comparator measure the difference of the decisions back to the data bits. Next slide. This diagram is a transmitter and receiver block diagram. The transmitter block diagram is send a message to noise and transmit. There are rectify the frequency error or signal unwanted signal errors. They rectify here, and then go to the receiver block diagram. The original signals. Next slide. This is the Dpsk waveform diagram. It represents fast shape. It represents zeros and ones only. And then 0 is down, is up is 1. Is represent fast shape. And then second is the up and down is represent the model waveform of Dpsk. Next slide. Now we see the advantages of Dpsk. The Dpsk offers a simple of receiver is without no need of the coherent phase reference. He delivers the output, and then it more tolerant of the phase noise, and then frequency shift the coherent of Psk. The receiver only needs of compare the consecutive symbols, and then the complexity of power consumption, which is more important used in mobile device, and then it works only the optical communication and wireless environment. Optical communication is example of flight and wireless environment is the Bluetooth. And next slide. This is the advantage of Dpsk. The bit rate performs the coherent of Psk of same condition, the sensitivity of timing errors. The Dpsk is noise also increasing error rate in small external is also in the increasing error rate. So Dpsk have the more error rate, and then Dpsk is more complex the error correction to compare to the simple of on-off keying, and the despite of more disadvantage of simplicity of many application use that Dpsk. In our next application of Dpsk, first one, optical fiber communication. Optical fiber communication means is a connector between light or sounds, and the wireless communication system means the example of Bluetooth, and then satellite communication is direct connected with the satellite for through in internet, and the military communication means there is to communicate with the act of no other any destruction of noise. It's easy to connect with each other. Dpsk is helps to connect with each other. Next slide. Future trends in Dpsk. The communication systems are involved an important role in the next generation of Dpsk, and the researchers are working the Dpsk error rate of increasing and reduce the error rate of PR, and then the more efficient and easy to maintain for Dpsk. And next slide. Conclusion. The Dpsk is simple and efficient for the data transmitting the easy without any coherent phase reference, and then it is easily to for low complexity, and then increasing the error rate, and then coherent method, and then is using many real world applications also, and then some of key modulations out there, and then fiber optics, and then satellite and military, and then some of communications also using fiber Dpsk. And next. Thank you for watching this video.